Hi everyone, welcome back to my channel. In today's video, we'll go step by step through an important topic in chemical process calculation, the salt solution analysis. Here, we'll learn how to calculate the weight percentage, then molality and mole fraction. Now here is the problem statement. A sodium chloride solution is prepared by dissolving 20 gram of NaCl in 180 gram of water. Here is the given data: mass of solute MnACl, so that is 20 gram, mass of solvent 180 gram, molar mass of NaCl MnACl, that is 58.5 gram per mole, and molar mass of H2 18.0 gram per mole. Now here our objective is: first, calculate the weight percentage of NaCl in the solution; second, determine the molality of the solution; and then compute the mole fraction of the both NaCl and H2. So first, step number 1, that is weight percentage of NaCl calculation. So first, what is weight percentage or mass percentage? That represent the mass of solute per 100 grams of total solution. So here is the formula: weight percentage M solute by M solution into 100. So M solution is equal to M NaCl plus M H2O. Now here is the calculation. So first we have to calculate the total mass of the solution. So total mass of the solution is 20, means mass of NaCl plus mass of 180 of water. So that is 180. Total is 200 gram. Now from here we can calculate weight percentage. So weight percentage is 20 by, 20 means M solute 20 divided by mass of solution into 100. So that is 10%. This means 10 gram of NaCl is present in every 100 gram of solution. So next is the molality of the solution. First, what is molality? So molality is defined here is as number of moles of solute per kilogram of solvent. So here is the formula: molality is N solute by M solvent. So N solute can be calculated. N solute is nothing but the number of moles. Okay, moles of the solute. So N is equal to mass by molar mass. Now first here calculate the moles of NaCl. So NaCl is mass of NaCl by molecular weight of the NaCl. So 20 by 58.5. So that is 0.3419 mole. Now here convert mass of water to kg. So we know water is present in 180 grams. So we have to convert into kg. So that is 0.180 kg. Now from here we can calculate the molality. Molality is N NaCl by M of H2 kg. So N NaCl is 0.3419 divided by that water solvent. So that is 0.180 kg. So that is 1.898 mole per kg. So we can write that is 1.9 m molal. Next we have to calculate mole fraction of NaCl. What is mole fraction? Mole fraction of a component is the ratio of moles to total moles in the mixture. So individual mole by total mole, we can say that. So formulas here, that mole fraction of NaCl is N NaCl, mole of NaCl by total mole. N X H2O, so that is N of H2O by N total. So here N total is that mole of NaCl plus number of moles of water. So here important property, sum of all mole fraction should be 1. Now we have to calculate the mole fraction. So here first, step number 1, what we are going to do is first calculate moles of NaCl. So in NaCl is we already calculate, so that is 0.3419 mole. So previous calculation. And calculate moles of H2. So mass of water by molecular weight of water. So 180 by 18.0. So that is 10 mole. So now total mole will be moles of NaCl plus moles of water. So that is 0.3419 plus 10.0. So 10.3419 mole. Now from here calculate mole fraction of NaCl. So that is X NaCl. So individual mole by total mole. Individual mole of NaCl is 0.3419 by total mole 10.3419. So that is 0.03306. And calculate mole fraction of H2O. So that is 10 individual mole by total mole. So that is mole fraction of H2O is 0.96694. So now here is the verification. If we add 2 mole fraction, so that must be 1. So here 0.033 0.03306 plus 0.96694, so that will be 1. So it is matching. So now here the final summary uh, of the my calculation. So that is weight percentage, that is 10. We got that result in the previous calculation. Molality is 1.8899 mole per kg. Mole fraction of NaCl is 0.03306. Mole fraction of H2O, that is 0.96694. That's it. Thank you.